Hello, 8th graders. Your last video is for section 10.4, which is on two-way tables. And so a two-way table is useful when you need to organize and display data that pertains to different categories. So to be able to do these, you need to understand what frequency means, and that just means you're counting up the number of times that an item occurs. So for example, I have 30 students that were surveyed about their favorite type of lunch. 6 girls and 8 boys chose turkey sandwiches. 7 girls and 3 boys chose grilled chicken. 4 girls and 2 boys chose veggie pizza. Make a two-way table of frequencies for the data. Use the frequency table to determine the least popular lunch choice in the survey. All right, well, first step is to choose the categories. And so I have already done that on my table. I need to somehow tally up the votes for turkey sandwiches, grilled chicken, and veggie, so I put those on the top, and then I need a total. And then I need to also separate the girls' votes from the boys' votes, and I need another total. So this is a two-way table. And so you read it kind of like a times table, where the two meet is where you put the numbers. So right here, turkey sandwiches and girls, that's where their votes go. So how many girls liked turkey sandwiches? Looks to me like 6. How many girls like grilled chicken? 7. How many girls like veggie pizza? 4. So total going across there is 17. And I come down to the boys. Boys that like turkey sandwiches, 8. Boys that liked grilled chicken, 3. Boys that like veggie pizza, 2. For a total of 13. Then I need to add them up this way also. So turkey sandwiches got 14 votes. Grilled chicken got 10 votes. Veggie pizza got 6 votes. And there were 30 total votes. So now that I have this filled in, I should be able to go back and answer the question. It says use the frequency table to determine the least popular lunch choice. Well, which one had the least amount of votes? Veggie pizza only had 6 votes. So there you go. There's the least favorite lunch. Then we're also going to work with relative frequency, which is the ratio of a frequency to the value of the corresponding row total, corresponding column total, or total population. And so here I have a table that's already filled in, dealing again here with hair color and eye color. So across the top, I have the hair color, which is blonde, black, and brown, and then I have a row for the total. Eye color, blue, green, and brown, and then I have a total column. And so I've already done that, like it's already been done for you, but we're going to use this one to be able to, excuse me, answer the questions that we have here. So it says, on the bottom, it says, is there evidence that brown eyes are less common for students with blonde hair than for those with brown hair? Explain your reasoning. Okay, well, we're going to make a relative frequency table using this information. So we're going to take this info and we're going to put it into, if you look back at what relative frequency says, it says the ratio, right? So we're going to use ratios in our second table. So I'm going to start with blonde-haired, blue-eyed people. How many of them were there? How many had blonde and blue hair? If you go back up here and look, 3 of them did out of how many? 6. 3 out of the 6 that had blonde hair had blue eyes. So when I come down here, I'm going to write it as a fraction, and then I'm also going to change it to a decimal. I could put a percent in there also, I guess, if I wanted to, but we should be able to tell just from these. Okay, then I'm going to go back up. How many black-haired with blue eyes? Looks like 1, right? Out of 9 black-haired people. So 1 out of 9, which would come out to be 0.1 repeating, right? So go back up. How many brown hair, blue eyes? Brown hair, blue eyes. 2 of them out of 10. So fill that in. 2 out of 10 equals 0.2. Then I'm going to come down to Notice that on this relative frequency table, I don't have a total column over here. The reason for that is because these blue-eyed people, you see how they're all at a different number of votes or a different number of people? Like you can't add those up. They're not the same thing. We can add up all the blonde-haired ones, right? And all the black and all the brown. That's why I have a total down here, but not over here. So how many blonde-haired, brown-eyed people do we have? And here I have this one in a different order for some reason, so I got to be careful. We're doing brown-eyed, so 2 out of 6. 2 out of 6. Whoops. Equals 1/3, so it'll be 0.3 repeating. And so then my next column would be the black-haired, brown-eyed, so it's right here. So that would be 7 out of 9, which would be 0.7 repeating. And then the brown-haired is right here, and I have 6 out of 10, and that would equal 0.6. So now the green eyes. Gotta go up a row there. So here I have green-eyed, blonde-haired, 1 out of 6. So 1 out of 6, which is 0.16 with the 6 repeating. Black hair, green eyes, 1 out of 9. 1/9. So again, 0.111 repeating. Then I have brown hair, green eyes, which would be 2 out of 10. So that's 0.2. Then if I add them up and down here, if you add the votes up, you're going to have 6 out of 6, which you should have, right? Because it has to equal 1 or 100%, however you want to do that. Here these votes add up to 9 out of 9, which again would equal 1 or 100%. And here I have 10 equals 1 or 100%. So now I should be able to answer the question. It says, is there evidence that brown eyes are less common for students with blonde hair? So brown eyes right here. Students with blonde hair than brown hair. Well, how many blonde haired have brown eyes? 1/3. How many brown hair have brown eyes? 60%. 0.6. So here's our answer. 33% have brown eyes, blonde hair. 60% have brown hair and brown eyes. So brown eyes are less common. For blonde-haired people than brown-haired people. There's my explanation. I just proved it using these relative frequencies. Okay? So brown-haired people more often have brown eyes than do blonde-haired people. So 2-way tables, but there's several different ways that we can use them. So bring that information with you, and we'll talk about it more next time I see you.